or dilute. But we have the lead acid battery. It's a type of battery used in cars that known as the car battery, and it's produced 12 volts as EMF. So the electromotive force of our car battery that we use it to operate air conditioner and the radio, FM radio, and we have some kind of parts or some parts inside the car, we use just 12 volts. It's very small amount of volts, yes, but we have this amount make operation of all things here. So the volts as EMF, electromotive force, as we suitable for operating option of cars, operating all options of car used by the car battery. After what? After making contact key of the car that start this reaction or start this connection to produce the electric energy for all parts of the car. After that, it's very important to know the structure of each one. Here we have it consists of 6 cells connected in series connection. Anode is a network of lead filled with paste of lead dioxide. Again, we have this is anode. That's network of lead filled with a paste of lead dioxide, PpO2. And we have another thing. It's the structure. It's the plates of PpO2. So we have separated by an insulating sheets. So we have the spacer. It's insulating sheets to increase to make the time very long to use this part of electric cells. Dilute sulfuric acid, it is an electrolyte. What's meant by electrolyte? It means what? It means a chemical compound that used to start the chemical reaction in batteries, to start the chemical reaction that change into electric energy. So here this is dilute sulfuric acid. It is work or operate as an electrolyte. So after that we have another shape of this car battery. We have some plates. Each plate we have 6 in each one. Here we have 6, here we have 5, here we have 5, and so on. So the plates here, it made of lead and lead oxide, okay, and the connection between them, and each one of these cells that's immersed inside inside H2SO4 as an electrolyte. And here we have the body that made of plastic or heavy type of plastic that doesn't affected by the acid. It's very important to know this. The body of this car battery, it's made of a type of plastic that doesn't affected by H2SO4 as an electrolyte. So the lead acid battery, it has this shape. And after that we have another shape that go inside this lead acid battery. We have casing, and we have positive and negative poles that found in the battery, and we have the 2 poles that appears like this. Here we have 1 pole and the other one is here. It's 2 pins that we use it to recharge this type of cells to change the electric energy into chemical energy again after finishing in the first time. And after that we use this one to connect the cables of electric energy or electric wires to operate all parts of the car here. So the pins here, it means positive, it's connected to the positive and negative pole to make to start the reaction and to connect the electric energy from the chemical energy that starts by chemical reaction between Pp or lead and lead oxide and the electrolyte of H2SO4. So here it consists of another part of this lead acid battery. It's container made of solid rubber or plastic material. Polystyrene, it means it means a type of plastic or rubber that makes that doesn't affected by acid. It doesn't affect by acid completely. It's a type of insulator again. The total reaction occurring in lead battery cell, it's Pp plus PbO2, lead plus lead dioxide or lead oxide, plus 4H positive. It comes out from H2SO4, and we have 2SO4 ions of sulfate. Again, we have the reactants here. So the reactants is lead plus lead oxide plus H2SO4, but here we have ions that found in the solution because it is dilute solution of H2SO4. So PpSO4 is produced, and we have H2O. If the PpSO4 or lead sulfate produced and the water produced, so the reaction will be stopped. Why? Because here we have no movement of the ions like H positive or SO4 negative to make the chemical reaction and change it into electric energy. After that, we have EMF 2 volts of each sheet, 2 volts of each one sheet of the lead or lead oxide. So the total of this one, or the total of these 6 cells or 6 sheets of lead and lead oxide, that makes what? That makes total equal 12 volts as a total value of EMF of what? Of the car battery. So last time, it's very important to know the total reaction occurring in lead battery cell. It's what? It's lead plus lead oxide plus 4H positive and 2SO4 minus 2 as an ions. So here we have PpSO4 plus H2O. So the EMF equal 2 volts of each sheet, and the total EMF of the battery equal 12 volts because we have 6 sheets of lead and lead oxide. After that, the reaction occurring in the lead battery, we have Pp plus SO4 minus 2. It's give us lead sulfate and losing 2 electrons. These 2 electrons is electric energy to pass from the car battery to what? To any part of the car to operate it. And after that, we have the EMF of this one. It's positive 0.36 volts. After that, it is an anode. And we have the cathode. Cathode, we have lead oxide plus H2SO4 in form of ions, H positive and SO4 negative 2, plus 2 electrons that produced from the first reaction of anode. So the PpSO4 lead sulfate plus water that formed. So here we have the EMF. It is positive 1.69 volts. As this exercise, calculate the EMF for the lead acid battery. So here we have 1.69 plus 0.36 equal 2.05 volts, nearly 2 volts of each sheet of this battery. Now we have Faraday's law. What's meant by this Faraday's law? Faraday, it is the scientist that discovered the electric energy and make relation between the chemical energy and the electric energy by using the quantity or amount of electric charges. So here, Faraday has deduced that the relation between the quantity of electricity which flow on the solution and we have quantity of material liberated at electrodes. What's meant by this? It's very difficult. No, it is very easy. We have a Faraday, this scientist had deduced the relation. It's found or discovered the relation between what? Between quantity of electric energy or quantity of electricity as a form of charges or coulombs, measured by coulombs, which flow in solution, and the quantity of material liberated in the electrodes, at electrodes. So we have this one. It's what? It's the Faraday. And we have 2 laws of Faraday. Faraday discovered 2 laws to calculate this amount of electric energy and the amount of chemical energy that produced from this. Here we have, it can simply form verified by what? By passing different quantities of current in the same solution and calculating the ratio of masses of the formed of what? Of the materials or from materials at the cathode. Again, it can simply verified by passing different quantities of electric current that pass inside the electrolytes or some kind of electrolytes that form of chemical compound or salt solution, so I need to know how many coulomb to use it, or I use it to make what? To make this reaction complete, or to make the precipitation of some chemical compound, or to produce a metal, or to separate a metal from this compound. So it's what? It can be simply verified by passing different quantities of electric current in the same solution and calculating the ratio of masses of the formed materials in the cathode. So here we have what we have, or another thing, or dissolved from the anode, and on comparing these ratios by what? By the ratio of passing quantities of electricity. So we have a rule. First law of Faraday, quantity of electricity, it's equal. We have what? We have quantity of electricity. This comes out from what? From the physics. We have quantity of electric energy equal the current strength by ampere times second times time per second. Again, quantity or Q, it means quantity of electricity equal current strength or current or electric current by ampere times time. So I use this law to calculate the amount of quantity of electricity by using current strength. So the quantity of formed or consumed material at any electrode, if it's what? It's gas or solid, so it is directly proportional to the quantity of electricity that passes in what? In the electrolyte solution. It's what? The quantity of that formed of or consumed material at any electrode if it's gas or solid, so it is directly proportional to the quantity of electricity. If the amount of this mass produced is very large, so the quantity of electricity is very large, but the quantity of electricity is very low, so the amount or mass of this separated material from its compound, it's what? It will be very small. So the quantity of electricity that passes in the electrolyte solution is directly proportional with the mass of solid or gas that's what? That consumed or formed from this what? From this reaction. And we have the second law of Faraday. It's very important to know this one because we use it to make what? To make some calculations here. This mass, the masses of different materials formed or consumed, this is the definition of this Faraday's law, Faraday's second law. The masses of different materials formed or consumed by the same amount of electricity are proportional to equivalent masses. What's meant by equivalent masses? Equivalent masses, it means the mass number or the atomic weight of the atom divide its valency. So the equivalent mass, again, it means what? It means equivalent mass, it means the amount or the atomic mass or the atomic weight of the atom or the metal or the substance that's divide its what? Its valency. Positive 3, negative 3, positive 2, 1, any one of these valencies. So the masses of different materials formed or consumed by the same amount of electricity are proportional to equivalent masses. For example, the masses of formed material that are hydrogen, silver, copper, any one of them, are proportional to their equivalent masses as the following, like this. So here we have hydrogen, silver, copper. It means what? Here we have the hydrogen, it is very small atom. It is the least atom in its size, its mass, and so on. Why? Because it has one proton. So the hydrogen, it is 1. The equivalent mass is 1. Silver, equivalent mass is 107.88. Copper, it is less than silver. Silver, it is very large one. So the copper is 31.78, and so on. If I have large atom, it has large equivalent mass. And if I have very small amount or very small atom, so I have very small amount of equivalent mass. So related to the second law of Faraday, we have what? We have hydrogen, silver, copper. they are different to each other in the equivalent masses. Why? Because hydrogen, for example, it is 1. 1 divide 1 equal 1. 1, it's what? The first one, it's the atomic mass or atomic weight, divide the valency is 1. So 1 divide 1 equal 1. Silver, it has mass number, it's very large, 107. We have mercury cell, the second one of the primary cell. Mercury cell, it means what? It means it is a part, or it's one of what? Of the primary cells. It is the same idea of what? Of the chemical reaction that produce what? That produce electric energy. It is manufactured in the shape of cylindrical or cylinder or disc. It's cylinder or disc, the shape of this one. It's used in earphones, it's very small one, yes, in clocks, in watches, in many small toys, in the device that used to measure the concentration of sugar in our blood. So the mercury cell, it is very important one because it is very small one. It's easy to transfer from device to another to operate one of them or many of them in the same time. So it's manufactured in the shape of cylinder or disc. It's used in earphones and what? And the clocks, many small toys. And we have some kind of devices that we use it to measure the concentration of what? Of the sugar in the blood. After that, this is the shape of mercury cell. Mercury cell, we have many shapes. One of them, it's Patton cell. It's what it is about, it is positive, and the other one is negative. So the above part, or here we have the first part or the upper part of this cell, it is positive, and this part is negative. Again, we have positive part and negative part. So this negative part, it's what? It is one of the chemical compound that makes reaction with the cathode and the anode. So here we have many shapes of what? Many shapes of this cell. So we have very small one like this, and we have very big one like this. Why? Because here we have what? We have many of the devices that's different in the shape, different in size. So we use the electric cells to make electric energy or to produce electric energy from the chemical energy. It's suitable for each one of these devices until it what? It's a toy. So we have this one or this type of cells. It's very important to use it in many devices that operate by this type of cell that called mercury cells. After that, we have it consists of, it's very important to know the structure. زي ما قلنا قبل كده لازم أعرف structure of each type of cell, the total reaction of each type of cell. So we have the very important question about this, compare between any two types of cell. So it is very important to know these things, the structure and the total reaction and the poles of each one, the anode and cathode. So here we have negative pole that called anode. It's what? Zinc. Like what? Like the dry cell. It's anode, it's zinc chloride, it's negative pole. So here we have the positive pole, it's cathode of what? Of mercury oxide. It's new compound here. We have the positive pole or cathode, it's made of mercury oxide and graphite. Also we have graphite. Also we have a conductor. Also we have a non-metal that's good conductor of electric energy. It's very important one to use it in what? In the dry cell, any type of dry cell, any type of mercury cell, any type of primary cell. So here we have the graphite. It's found in all types of cell, almost all types of cell. Why? Because it is used as a conductor of electric energy, of electrons after the finishing chemical energy or production of electric energy by chemical energy. So it consists of negative pole or anode of zinc, and positive pole, it's cathode of mercury oxide, HgO, and graphite. Graphite is C. And the important thing, we have electrolyte of KOH. Electrolyte, it means the wet, like the wet paste of the dry cell. We have electrolyte, it's KOH, potassium hydroxide. After that, this is the structure of what? Of the cell that called mercury cell. We have the cathode, okay, in the lower part, and we have anode in the upper part, and here we have metal cap. Metal cap made of zinc, made of iron, made of stainless steel, made of any one of them. So the cathode, it's what? It is the lower part of positive pole, and we have the negative pole. It's found in anode, in the upper part here, that has red color. So we have the structure of what? Of the cells that found here. It's called mercury cell. Why we call mercury cell? Because we use the mercury inside it to make what? To make the reaction in form of oxide. I don't use the mercury as itself, as a metal. Why? Because it is a good conductor of electric energy and good conductor of heat energy. It is a metal, doesn't make any reaction. But I have, or I need the mercury to make what? To make the reaction as a form of ion in mercury oxide. Dear friends, I hope to enjoy your time with us. دايما أصدقائي الطلبة والطالبات من الصف الثالث الثانوي، دايما بنأكد على إن أنا أراجع كل الأسئلة اللي موجودة على الجزء اللي احنا بناخده مع بعض وبنشرحه مع بعض. سهل جدا وبسيط جدا، وأنا المفروض إن أنا أحل كل الأسئلة اللي موجودة في كتاب المدرسة وأركز فيها جدا وأحاول إن أنا أفهم كل كلمة فيها. Till we meet again in another session. Till we meet again, thank you and goodbye everybody.